Let's look at the first one here. Notice that everything has a factorial in the denominator, and it's all even numbered factorials and even numbered powers. So that might make you think of one of the Maclaurin series that we've already calculated and worked with, so that's cosine of x, right? So cosine of x's Maclaurin series is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, and so on and so forth. So it alternates with these even numbered factorials in the denominator and also even numbered powers of x. And then it keeps going. So I'm just going to write that down for now, and I'm going to show you if you just Google, let's see, here we are. If you just Google Taylor-Maclaurin series table, here is one that I found. And you can see here over in the cosine x, right, that there is indeed the even numbered powers divided by even numbered factorials alternating, starting with 1 as a series, right? So we're going to go back here and use this information to see if we can make sense of this particular infinite series. So if you compare that to the infinite series for cosine of x, the only difference is that instead of pi squared, we have x squared. Instead of pi to the 4th, we have x to the 4th, and so on. So it really seems like this equals cosine of pi. Because again, if we wrote out this series, it'd be 1 minus, now I'm looking at that one and plugging in here x equals pi, it'd be 1 minus pi squared over 2 factorial plus pi to the 4th over 4 factorial, dot, dot, dot. And this is reproducing this series that we started with. Okay, so to clean things up, right, our basic claim, now that we've compared the infinite series with the Maclaurin series for cosine of x, our basic claim is that this thing equals cosine of pi. So that would be the sum. Now, very important, right? We have to also make sure that we are within the interval of convergence. In other words, this is cosine of x at x equals pi. So question, is cosine of x equal to its Taylor series or Maclaurin series at x equals pi? And the answer has to do with the interval of convergence for that Taylor or Maclaurin series. And we know that cosine of x actually does equal its Maclaurin series, oops, it's even, which is this, 2n factorial, n equals 0 to infinity, for all real numbers. Okay, so the fact that x equals pi, x could be any other number, wouldn't matter, because it's for all real numbers that cosine of x is actually equal to its Maclaurin series. So we're good, right? So we can actually claim that this really does equal cosine of pi. And we happen to know what cosine of pi equals. That's -1. So the final answer is that this series sums to -1.